because Naresh Shetty team is very active for this kind of things. Whenever if you do all these kind of things, easily you will get caught and unnecessary you will be in legal issues. So I don't want my people, you people, to be into that troubles. So I'm not telling to everyone. There is one or two people will be there, so who might be doing purposefully. So please take care of it. Okay. Okay. So with that being said, I hope you had a nice vacation. And what did we discuss in our last class? Docker project, and then we have completed, right? Fantastic. Docker done. Docker done. Okay. Docker done. Yeah. So today, let's go to the next topic, which is Kubernetes. What's that? Kubernetes. So before going to this Kubernetes, right? So we should be knowing why, what, and how. You know that in Docker we have learned very deep all the containers, images, Docker Compose, and latestly, I mean, we have done the projects, and latestly also we have learned one Docker, one concept, which is called Docker Swarm. Which one? Docker Swarm. So Docker Swarm, why? What is the purpose of Docker Swarm? High availability. Fantastic answer. What's that? High availability purpose. So initially, we used to launch only one EC2 instance, installing Docker on it, and then creating the containers. You are creating the manual containers. If you want to automatically create the containers, you went for Docker Compose. But when you go for the Docker Compose, still you are creating multiple containers in one shot using Docker-compose up-d command. But still all the containers will be on the single machine. I think people can hear me. Screen share is coming. Okay. మళ్ళీ ఆఫ్ అవుతుందిగా మళ్ళీ పోతుంది కదా ఓకే కనెక్ట్ అయింది ఓకే సో బాస్ ఈస్ బ్యాక్ బట్ అగైన్ ఆన్లైన్ కెన్ యూ కన్ఫర్మ్ కెన్ యూ హియర్ మీ oh acha, I was humming okay acha and please I think now here it is running on generator. You might experience one more cut after once the power comes online. So please wait for me. So once the power is back again, so I'll be connecting. Meanwhile, let's move on. Okay. But please expect one more disconnect because it's running on the generator now. Okay. So I was talking here. Yeah, we were creating the containers manually, and then we created the containers automatically using Docker Compose, right? And then even the Docker Compose multiple containers are running on the one single host machine only, in single host machine. But what happened if just in case if that host machine goes down, all your containers are gone? So for that reason, what we have to manage the containers, to manage the containers efficiently, to manage the containers, what we have, we got Docker Swarm. So managing the containers, we call it as work orchestration. What we call orchestration. So can we call Docker Swarm is also an orchestration tool? Answer is yes. So what is the meaning of orchestration? Orchestration is nothing but cluster. Simple as that. Simple. If you ask any layman guy, what is orchestration? So without having much definitions, simply you can say it is a cluster. What is a cluster? Group of servers. What the Docker Swarm we did? We had a leader node, I mean master, and then we have the worker nodes or not? Yes or no? So we have master and then worker node. Say with me. One more time. One more time. So master, and then instead of saying slave, call it as worker node. It's better to say, right? Master and then worker nodes. So we can have one master and we can have multiple worker nodes or not. So Docker Swarm, we used it. We remember Docker Swarm init we did, and then we joined all worker nodes to this swarm, right? And then what we did, whenever we create any service there, right? What it create? It creates the multiple containers in all the machines or not? Let's say you have 3 machines, and I have run a Docker service, and the replicas as how many? Let's say for example 10. If I say 10, so in 3 machines, all 10 containers will be equally distributed or not? Let's say for example, you have node 1. Which one? Node 1. In node 1, how many are there? 5 are there. Assume that 5. So, and what is that application that we use? HDFC application. Remember HDFC? So, HDFC application. And then if you have internet banking running, one node contains multiple Dockers with the same application. Yes or no? Using Docker Compose, in Docker Compose, you cannot run multiple containers with the same port number because host port should be only one. So conflict came. Remember when I was scaling up, when I was scaling, conflict came because already ports are getting allocated. But if you went to Docker Swarm, in one node, you can have multiple containers with the same port. If one container also goes wrong, automatically self-healing came up or not? If one container we crashed it or we stopped it, we killed it, automatically new container will come up. And also one node contain multiple containers with the same application. One node contain multiple containers with the same application. What is that? Same application. So that meaning if I connect to the node 1, in node 1, 5 containers are there with the same application. One node contain 5 containers with the same application. Now, if customer is accessing that node, So the node is responding with the application to the customer or not. But just in case if 2 containers goes down, so still my customer is using or not. Another one is goes down, my customer still is using or not. But if it will never go down, because if one goes down, again it will come up. Again it will come up. What is that called? Self-healing. What is that called? Self-healing. Meaning indirectly here, Docker Swarm is giving our load balancing. Yes or no? Docker Swarm is giving us what? Load balancing or not? What is load balancing? If one goes down, equally distribute the traffic or not? So you have one node contain 5 containers and 5 containers. So this Docker Swarm is distributing to the multiple containers. So Docker Swarm also giving what? Load balancing and auto scaling concept. But this Docker Swarm is only for limited and small scale. In the small scale only it will work. But if you want to maintain huge deployments, if you want to manage multiple containers in vast, Docker Swarm will not be sufficient. And Docker Swarm has a limitations, right? Docker Swarm has what? Limitations. For that reason, we'll go with what? Kubernetes. For that reason, what? We go for what? Kubernetes. So in shortcut, Kubernetes is a powerful open source platform. Powerful. It's an open source platform. For what purpose? To automating the deployment, scaling, and operating all your application containers. If someone asks you what is Kubernetes, what do you say? Kubernetes is a open source platform for automating the deployments. What I'm saying, what? Automating the deployments, scaling, that can be scale outs, auto scaling concepts. So we can, and then operate of application containers. So if you want to operate multiple containers, you can manage the multiple containers easily using this Kubernetes. Understand? So if someone asks you, can you tell me what are the orchestration tools that you know? Then what are the 2 tools that you say? One is Docker Swarm, another one is what? Kubernetes. And which one is best to use? Kubernetes. Got it? So Kubernetes is like, for Kubernetes, we also call K8s. What we say? What we say, Nana, here? Do you know why K8s came? You don't know, right? See. Correct spelling. Correct, no? Kubernetes. K. How many letters? Huh? 8. This one is K and this one is S. They call it as what? K8s. Yeah, correct. Nijamana? Correct. Okay, that's why we call it as what here? K8s. Lazy people, right? Because instead of saying Kubernetes, so lazy people call it as what? K8s. Okay, fine. So, as I told you, this Kubernetes main job is to manage the containers. Say that? Manage the containers. And Kubernetes mainly is for use for clustering purpose. What purpose? Clustering purpose. Cluster meaning what? Group servers. So is it good to have only one server? 100% no. For that reason, so let's say for example, we have one server. Lot of traffic came inside that server. Is sufficient? No, definitely we need to have add multiple servers. Now one server was there and now we added 5 servers and you need to manage those 5 servers or not? Is it easy to manage it manually? Is it easy to manage with the Docker Swarm? No, for that reason we go for what? Kubernetes. So Kubernetes meaning the first thing that you should remember is cluster. What's that? In cluster is a combination of master and nodes. What we call master and. What is cluster? It's a collection of master and nodes. Nodes meaning here worker nodes. Master will be managing what? Nodes. When I say like this, online people cannot see my actions. Do you know for when Music directors. What they do, music directors. He'll be standing and yeah, what is it called? They are, yeah, Nandamuri Taman, yeah. Right, so what this guy, the composer will do, so he will be standing and then all the singers will be, I mean, the chorus people will be sitting in there and he will be managing from here with the hands or not. So that guy is nothing but Kubernetes. And the rest of the people, the composers there, I mean, not composers, the juniors who is singing all this orchestra, we call it as nodes. Understood? So managing properly all these people will be done using the composer. Here, managing all the containers will be done by the Kubernetes. Understood? I gave a good example for this. Remember in Docker also, I gave that example of Sanjeevani, right? Yeah. Right? Yeah. Fine. So this is what I try to put it here. See with me, guys, here, everyone. What is Kubernetes? Kubernetes is a powerful open source platform for what purpose? Automating the deployments, scaling, and operation of application containers. So Kubernetes is also known as what? K, managed, what's in here? Containerized app. Correct, Abhishek. Very good. Okay, Nana. Let's say, for example, you have only one node. You have only one node. If you get a heavy traffic on the application on the particular node, this node will go down completely. So for that, what we need to do, immediately you need to set up multiple nodes or not? If you want to set up multiple nodes, you have set up multiple nodes. But how do you manage these multiple nodes at one shot? You need to manage it, right? But it's not possible for you to manage manually. For that reason, we go with the concept called Kubernetes. So Kubernetes is mainly used for cluster purpose, high availability purpose. As you have high availability, can you easily do load balancing or not? Remember high availability concept, our AWS, RMF. So redundancy, monitoring, failovers easily can be done in the Kubernetes. Everything is self-healing, everything is super automated. Okay. When we deploy Kubernetes, what we get? We get what? Cluster. What we get in here? Cluster. Cluster meaning two important parts here. What are the two important parts here? What we call it as master and then worker node. Say with me. Today is theory. I want to inject that bloody theory in your brains, and the wordings in Kubernetes are very important. The terminology is important. Okay. So when I ask you to repeat, please try to repeat so that it will be in your subconscious mind. So whenever I create a cluster, what are the cluster meaning? Combination of nodes. What are the two nodes? Master node, worker node. Here master node, we also call it as control panel, or we call it as control plane. What's that? Control plane. Control plane. Say control plane. What's that? Control plane. So it's not good to say panel here. Call it as control plane. So this is a place where you control everything, correct? So this is the place where master is the guy who will be controlling all the worker nodes or not? Yes. And do you see this in here? See, this guy, you can assume me, but I'm not like this. He has a okay. So somehow this guy, someone, right? And then all these people are what? Docker containers. What are those? Docker containers. And who is this guy? This guy is Kubernetes. And do you see the logo of it? I already told you this. You have ship. You have ship. What does the ship contains? Containers. What does the ship contain? Containers. The ship here is Docker engine. The bottom, the floor is what here? Docker engine. On top of it, what you have? Containers. But the driver will be there, no steering. And that steering is Kubernetes. That steering what here? Kubernetes. So what is this steering driver will do? Captain will do here what? Was that chicken? Was that chicken meaning? Okay, so the steering, huh? Okay, so in steering, we call it as what here? Steering, where that steering is nothing but here, Kubernetes. This steering will manage the entire ship or not? This steering is managing the entire ship. Indirectly, the steering here means Kubernetes is managing the entire containers in the back. Maintaining the containers in the back. So that is the, yeah, that is the whole concept of Kubernetes. So Kubernetes will manage the what, Nana, here today? Containers. And Kubernetes, we will start with the concept called here cluster. Cluster is a combination of master and what? Nodes. Master and what? Nodes. Master is also called what? Control plane. Say that louder. This word is very important. What is that? Control plane. So you can call it as master also, or you can call it as what? Control plane also. And what are these are all called? Worker nodes. Say that. Say that none here. Worker nodes. Online, is this clear till here? Okay. Hmm. Correct. Exactly, correct. So that's what the problem, no? So in Docker Swarm, you cannot go for the massive things, right? You can have with the only lower audience, you cannot, it can be vastly scale, you cannot do, right, much. So Docker Swarm will do the load balancing, but it will not be up to the level. And then we have the disadvantage of auto scaling also there. So in Kubernetes, mainly what we'll do, it is the enhanced level of the Docker Swarm. Next is Kubernetes. In Kubernetes, easily we can do what? Load balancing. Easily we can do what? Auto scaling without any port conflicts. Hmm? Thank you, Karthik. Okay, so is it clear till here, everyone? So the output from this paint here is two things. Kubernetes contains what? Cluster. Say that Kubernetes contains cluster. Cluster is the combination of master node and worker nodes. How many masters will be there? One. We can have many, but let's go with only one for now. One master and then multiple worker nodes. What is the what is the master node also called as? Control plane. Okay. Now, sir, what does the master node contain? What does the node contain? Right? We should know the architecture of the Kubernetes. So for that, let us go and learn. But here, the twist here is Kubernetes is steering in the ship. It is driving. What is there in the back? Containers. What is there in the back? But the Kubernetes doesn't know what is. Can you hear me now? Okay, can you hear me now? Okay, no, fine. So as I said, I was giving one small twist and then voice gone. So Kubernetes is managing what? Kubernetes is managing the containers, I said, but Kubernetes doesn't know what is container. Kubernetes has an another layer on the container. We call it as pod. What we call? Pod. Say that. Pod. 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 Say that. Pod. Pod. So what does the pod contain? Container. What does the pod contain? Container. Kubernetes will see only pods, but not container. Kubernetes doesn't know container at all. Kubernetes can see only what? Pod. Pod will Yes. Okay. Online, can you please confirm? Can you see my screen and can you hear me well? Acha. Yeah. Sea waves are disturbing the captain. Yeah. Yeah, but that that voyage, I traveled from Helsinki to Tallinn and Stockholm in Europe by ship, and the ship will dock in the mid of the sea without traveling because it will just stay over there, and it was completely frozen sea, frozen. And then our ship is an icebreaker ship. We call it as icebreaker ship, where it will break the ices and then it will travel, right? So it was really such an experience. And we used to go on the deck. We call deck meaning we'll say top. So when we go on the top, you cannot even manage to stand. Impossible. Just imagine in the sea, frozen sea, lot of air, and you cannot even hold your phone in your hand without gloves. Very dangerous. Okay. Yeah. All right. So let's move on. I was telling that Kubernetes doesn't know what is container. Kubernetes only know what? Pod. What does a pod contain? Container. Say that. What does a pod contain? Containers. So whenever in Kubernetes, we always talk about pods, not containers. But what is there inside the pod? Container, obviously. So Kubernetes also has a Docker engine. Kubernetes also has what? Docker, because container need to run, right? So in order to run the containers, what we need to have? Docker engine. In order to run the pods, we need to have Kubernetes. You need to have what? Kubernetes. So as I'm telling you, cluster. Kubernetes is all about cluster. Cluster is a combination of nodes. What are those? Master node and then worker nodes. So what is the master node? Also call it as control plane. And then we have the worker nodes. Now let's go to little bit more further. Exactly, Komala Rama has put now. He has a cluster. What does a cluster has? Nodes. What does the node contain? Pods. Pods contain what? Container. So Kubernetes commands will deal all the time with the pods only. There is no command such like need to call it as like in Docker, how we write containers and all. No concept at all here. Only pods. Okay, so let's go to very important topic, and you will get a lot of interview questions here. As I told you, what is a pod? Pod is a single instance of running process in the container. Simply, pod contains what here? Container, where your application runs. So in Kubernetes, everything we call it as object. What we call? Pod is a object. Pod is a object. Remember in Docker, we learned about volumes. Volume is a object. Everything is an object in the Kubernetes. Pod is also, we call it as what? Object. What does the object contain? Container. What does the container contain? Application. So we can call it as pod, meaning a single instance of running process, a single small object running process inside the cluster. Cluster meaning big thing. Inside that, the smallest object, the smallest object that Kubernetes will create is pod only. Smallest object. Which one? Pod. Okay, now what we have done here, master node and then worker node. Say with me. Master node and then worker node. So master nodes has so many components here, right? Say with me, Kubernetes, right? So in Kubernetes, what is the first four letters called? So that is the most commonly used word in Kubernetes. What we call cube. Say that. In Kubernetes, what is the first four letters? Cube. So what is, and then for every component, what we call it here, it is cube and then name. Okay. So this one we call it as master node. What is we call? And this one we call it as what? Worker node. Say with me, this is called master node and this is called worker node. So let us see here what is the architecture of our Kubernetes. So no, Kubernetes meaning it not just like a yum install Kubernetes and then boom. Believe me, Docker is very easy. Kubernetes is difficult. But in our dictionary, there is no word called difficult. Everything I make it simple. But to set up Kubernetes, people feel it is difficult. Compared to Docker, it is little bit more lengthy process. In Docker, what? How to install Docker? Yum install -5 Docker systemctl start Docker. Ho gaya, bas khatam. And then Docker run -itd. Everything you write it. But Kubernetes is not like that. Okay. Only Nana told Tausif bhai, Nani bole nahi. Right? Okay. So Kubernetes is I cannot say complicated, but installation. If someone asks me, if someone asks you what is the difference between Docker and Kubernetes, the first thing what they say is installation of Docker is easy, installation of Kubernetes is difficult. Difficult meaning not for us. Compared to Docker, it is difficult. Compared to Docker, it is difficult. Okay, fine. So for that reason, Kubernetes have a lot of architecture. So there are so many components inside the master node. There are so many components inside the worker node. So let us go with the first one. Which one? Master node. In that master node, we have something called API server. Say with me. One more team. Put a cube in front and call it as cube API server. Say that. What is the second one? Cube scheduler. What is that? Cube share. But don't say cube etcd, but the etcd only. But here we call it as cube API server and cube scheduler. But it's okay, call it as API server also, no problem. See, what is the first thing what we have? API server. Say that. Now in Docker, what you did, you have the CLI, right? And you write as Docker images, enter. Docker images, enter. And you write Docker ps-a, enter. So when you write, I told you the architecture of Docker also. That is called Docker client. Whatever the commands that you're writing is Docker client. What is there in the backend? Anyone? Before Docker daemon? What API? REST API, no? REST API, no? Remember? So everything, whatever we write the command will go and talk to whom? API server, API REST API in the backend. That is in Docker REST API. Here we call it as API server. Here we call it as what? API server. What API server? Kube API server. So whenever we log into the machine, install the Kubernetes cluster, and then we need to write the commands, right? All the commands, Kubernetes commands that you run, let's say Kubernetes commands that you run, every command will go and talk to whom first? API server. What is that, Nana? And I'm telling you guys, many people have difficulties to remember all these things. But if you concentrate my class, you can easily remember the components. See, what the API server will do now? It will receive, it is like receptionist. It is like receptionist. What is receptionist? Who will receive, right? Whoever comes to that office, what they do? They will receive it or not? So here, whatever the commands that we provide, who will receive it first? API server. Say that. API server. But don't worry about the definition. Just understand what is the each component is doing. Okay, now we have Docker client, no? In Docker, what we have? Docker client. Docker client is nothing but whatever the commands that you're running is the Docker client. And what is the command that always in the Docker start with? What is the command? Docker. Say that. What is the command that will start in the Docker always? Docker run, Docker PS, Docker images, Docker something, everything with the Docker only, right? Now replace that Docker. Docker is the command in Docker. But in Kubernetes, we call it as kubectl. Say that. Say that. I told you in Kubernetes, first take 4 letters. Kube, CTL meaning control. Your entire Kubernetes is getting control using what command? Kubectl. till end of the course, till end of the Kubernetes, we go with what command? kubectl. Understood what kubectl is? kubectl is the guy who will be communicating with the API server. Docker is the command who will be communicating with the REST API server. Here, kubectl is the command who will be communicating with API server. Kube API server. Which one, Anna? Here, Kube API server. So what is the, okay, I'm asking the question. What is the command to communicate to the API server in Kubernetes? kubectl. What is the command that you regularly use for any commands in Kubernetes? kubectl. Understood? Call it as client also, no problem. It's a tool. It's a command where every command that you write is with the kubectl. For example, what is the command to list the image, to list the containers? Docker ps-a. Here, do you list the containers or do you list the pods? Do you list the pods? kubectl get the pods. Say that. That's a command to list the pods. You can call it as pods also. You can call it as po also. Po. 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 What is that? What we call? Po. Po. Okay. What is the command to list the pods? kubectl get pods. You can say get pods also. You can say get po also. Po. Po. Okay. But which one is good to hear? Pods, no? Let's continue with pods. But many people in real time also, very lazy people, what they do? Po. Okay, yeah. Yeah. All right. Yeah. I forgot one joke. Yeah. So kubectl get pods. Fine. Is it clear, Nana, here? So what is it? So you already learned one command here. What is the command to list the pods? kubectl get pods. Every time, how we have a habit of Docker ps-a, how we have a habit in the git status. Every time they will git status. And in Docker images, Docker ps-a, like this, you should have a habit of listing the pods here. What is that? kubectl get pods. There is also one few people. I have been habituated saying that kubectl, but some people say call it as kubectl. What is that? Something different, no? kubectl. You tell me which one is recommended. kubectl is good. kubectl is good. ctl. Let's continue with what? kubectl. No ctl, no cuts, nothing. Let's go with kubectl. Decent language. Okay. Understood the API server completely now? And by the way, do you worry about all these things? Do you worry about all these things? Do you create all these things? Not at all. Everything is completely managed by what? Kubernetes itself. But we need to know based on the interview questions, we need to learn each and every component here. Okay, Nana. What is cluster? Group of servers. Call it as nodes here. Say that. Call it as nodes. What is cluster? Group of nodes. It's a combination of master node and then worker node. Okay. Now you created a pod. What you said? You created a pod. Now I'm slowly habituating the wordings here. You created a pod. When you create a pod, obviously it will create pods in multiple machines or not? Okay, it will create them. There should be in master some person. You have given kubectl, for example, create pod. For example, kubectl create pod you have given. How many? 4 pods example. You created a 4 pods. There should be someone who should take that request. API server will take the request. And API server will take the request and send it to one person. Hey, Babu, customer is asking to create 4 pods. You go and create it. You go and create it. API server will take only the request. Receptionist, what will do? What she will do? Only information. She will do the work. कौन करेगा काम अंदर? Here also API server will take the request and send it to one person here. Hey, customer is asking to create the pods. How many? 4 pods. But how many nodes you have? 2 nodes. You decide, Mr. Guy, new guy, you decide which node has to have which pod. Where you need to create the pod. Node 1 na node 2 node 1 में कितने pods, node 2 में कितने pods. You want to choose node 1 na node 2 node 1 is full node 2 is empty You decide. Who is the guy who is deciding? Scheduler. Who is the guy? We call it as kube scheduler. Say that. People call it as scheduler also, or people also call it as what? Kube scheduler. Now, kube scheduler, what it do? Assign nodes to newly created pods. So whenever the new, where does the pods need to be created? On the nodes only, no? Where should the pod should be created? On the nodes only. For who will be deciding which nodes need to be created in which pods need to be created on which node? Scheduler. Which scheduler here? Kube scheduler. Understood? Okay. Now, sound others already here. Ravi, is it clear, guys, online? Can you hear me? Yeah. What is the next component here? We call it as etcd. Say that. etcd. People also call it as what? etcd. Or else call it as etcd. Is fine. For Kubernetes is such a big thing, right? And it has to hold a lot of data, right? Where all the data is stored, generally in the database, right? So what is the database for Kubernetes here inbuilt is etcd. Where than here, it will have all the cluster information. And do you tell you one thing? API server is a pod. Scheduler is a pod. etc it is a pod. Everything in Kubernetes is in the form of pod. Just in case if etc pod is crashed, your Kubernetes will work, cluster. If API server is not reachable, your commands will work. You understand the logics, right? So, but these all pods are maintained by Kubernetes. So, which is like which is a component where it contain all the cluster information? etcd or etcd. Say that, etcd. Okay, what is the next component here? Control manager. Say that. Say that again. Cluster up, down, what is the state of it, how to manage the entire cluster will be handled by what? Control manager. As the name clearly says, it is managing the entire cluster, state of the cluster. Starting the cluster, stopping the cluster, taking care, adding the nodes, right? The entire cluster's responsibility will be taken by whom? Control manager. And by the way, don't worry, you just need to remember, you don't need to do any technical things here. So this is the architecture of the Kubernetes. So you should know in master node what are the components it has. Can you tell me what are the components it has without seeing it? What is the first? What is the command to? What is the command in Kubernetes that we run all the time? kubectl. Kubectl will talk to whom? API server. API server will give instructions to whom? Scheduler. And where is the database for the entire Kubernetes? etcd. And who is which is the component in the master node will manage the entire cluster? Control manager. There is also something called cloud control manager. What is that? Then a Kubernetes I'm setting up on the EC2 instance. What is the equivalent of Kubernetes in AWS? Louder. EKS. What's the full form of EKS? Elastic Kubernetes Service. Here you need to set up Kubernetes. You need to manage. You need to maintain. Master node, worker nodes, you need to launch EC2 instance. You don't need to that's a command, but Kubernetes need to manage everything. Machines. But EKS is completely managed by AWS. Run the commands from here to the EKS. Everything is managed. And I'll be promising you we'll be taking one project also on EKS. Okay. Okay. Now. Understood on the master node, everyone? Clear? Online? So once we learn about the master node, so the next what we need to go for? We go for what? Worker nodes. What we go here? Master is there. Master is there. And then we have worker nodes. Definitely we need to have agent, right? Kubernetes agent should be there, no? Yes or no? Kubernetes agent should be there. What this agent will do? In worker nodes, what is the job of worker nodes? The pod, and by the way, should I tell you one thing? This master Sala, this master server, Doesn't hold any parts. Master server will not hold any parts. Master node will just maintain. That's it. All the parts will be running where? Inside the worker nodes. Master server doesn't have nodes. नहीं handle करेगा. No. Right? For that reason, all the pods will be running inside the worker nodes. How the master will get connected to the worker node? Using the agent. Using what? Agent. Which is the agent in the worker node? We call it as kubelet. Say that. Not tubelet. Kubelet. What's that? Kubelet. Say that. Kubelet. So which is the agent is running inside the worker node? Sumalika, sir, scheduler will not assign pods to the master? No. Master is master only. It will not work. Master will not contain any pods. Okay, Sumalika. So here, who has the pods? Worker nodes has the pod. And can you tell me, who is the guy in the worker node will always talk to the master? That is the answer. These are all interview questions. So which is the component in the worker node who will talk to the master? Kubelet. Kubelet is the only component in the Kubernetes which will be in touch with master. You're getting the picture of architecture. Okay. Next, in the worker node, obviously we need to have the container engine or not? Our Docker engine. So what we call here, we call it as container engine, or we call it as container runtime. Container runtime. So, and also we have the pod here. We need to have a pod. What does the pod contain? Container. Container has what engine? Docker. Container is running on the Dockers. What does the worker node contain again? Worker node contain the kubelet. That is the agent, right? And then we need to have the container engine. Inside, and on top of the container engine, we have the pods. And what does the pod contains? Containers. And now, whenever you create a pods, definitely for every pod or a container, we need to assign the IP address or not. Your application should work. Without IP address, with application will work. There should be someone who should assign IP address, no? Kubeproxy. What's that? Kubeproxy. Kubeproxy is the guy who will maintain the network in the worker node. In the worker node. Who will assign the IP addresses? Kubeproxy. Who is assigning the IP address here? Kubeproxy. You understand the entire architecture? The entire Kubernetes will deal. But by the way, this one will not be talking again and again. This is just an architecture. It's just a architecture. So what we'll talk every day here is kubectl. Which one? What is the command to list the nodes? List the pods. Kubectl get pods. Everything will run with kubectl. Okay, should I ask you a few questions now? Ready? Online, without looking this, tell me the answers. Okay. Kubernetes is all about the cluster, creating cluster. Can we say the Kubernetes is an orchestration tool? Kubernetes is a orchestration tool. Can you tell me what is the another orchestration tool that you learned before? Docker Swarm. So what is the problem with the Docker Swarm? It cannot auto scale, and we have a less load balancing, less capacity. Basically, you have it. And then in Kubernetes, we have something. We create what? Cluster. What we create? What we create in Kubernetes? Cluster. What is cluster? Group of nodes. Group of nodes. What are those nodes? Master node and then master node and worker node. Okay. So coming to the master node. In master node, which is a component or which is the object or which is the command that you provide on the CLI? kubectl. Which is the command? Kubectl. Kubectl will talk to whom? API server. Can we say that API server is like a service which will be taking from the kubectl? All the requests will be taken from the kubectl, and it will go to which one? API server, and also call it as kube API server. Which one? Kube API server. Which is a component in the master node will assign the pods to the nodes. Scheduler. Which one? Scheduler. So which is the component in the master node which store all the cluster data and information? etcd. Which is the component which manage the entire cluster status? Control manager. Which is the component which will create clusters in the cloud? Cloud control manager. What's that? Cloud control. I didn't put it there, but it's a cloud control manager. So, okay. In the worker node, what is that agent called? Kubelet. What's that? Kubelet. And then, which is a component in the worker node will assign the IP address to the pods? Kube proxy. Say that? Kube proxy. And and what else you have? You have the container engine. On top of it, you have the pods. What are the pods contain? Containers. One single pod, better to go with one container. But one single pod can also have multiple containers. Answer is yes. But which is better? One pod, one container is good. One pod can also have multiple containers. But let's go with one pod. One container is always better. So with Kubernetes, we can do container orchestration. Yes or no? We can do the scalability. We can do the load balancer. We can do the high availability. We can do the rollouts and rollbacks. So when deploying the applications, if not, you can roll back also the versions. Is clear this paint? Correct. Dinesh. Guys, is this clear till here, everyone? Everyone clear? Super. Now, let's go the actual topics of the kind of like agenda that main topics in Kubernetes. So that by today's class, you should not be new to the Kubernetes at all. You should know the whole concepts of Kubernetes. Only practicals will be pending. Okay, so let's go with the key networking concepts. What is here? Networking. So mainly here we have 3 networking concepts. Say with me, very important. Cluster IP, say with me, cluster IP, node port, load balancer. I'll tell about these 3 things. You tell me which one is suggestible to choose, to use it. Cluster IP meaning it is an internal IP address that is assigned to any service inside the cluster. Let's say you created one application in the pod. It's all about service. What is here? We call it as service. So whenever you create any service inside the cluster, in the Kubernetes cluster, by default, Kubernetes will assign the cluster IP address, which will work only within the cluster. You cannot access from outside. Any use? Any use? Tell me honestly. No. Okay. Then we have a node port. What's that? Whenever you create any pod which has an application inside it, and then this, if you use the node port object, that means node port thing, you will assign, what the name says, node port. So your application will be working on one certain random port number. Is it good for you to access your application with the port number at the end? No. And then last one, what you have? Load balancer. So whenever you have an application and your application will be creating, and Kubernetes will be creating a load balancer for you, where you can just hit that load balancer where it will work nicely from outside also. So which one is suggestible to use here? But what are the 3 options that you have all the time? Cluster IP, node port, load balancer. Which one will you go for? Load balancer. But I'll go, but cluster IP will be there by default, but is any use of it? That IP will work within the cluster. But if you have node port, yes, that will also expose your application to outside world, but with the port number. What with the port number? Ranjit, very good. Now let's say database concept. Database are exposed to the outside? No, your database will work on a particular port number. Let's say MySQL is installed. MySQL install on the pod, and MySQL is running, and MySQL is working on which port number? 3306, for example, or Postgres 5432. So we need to expose that MySQL using that port number. In that case, will you go for load balancer? Which one you'll go for? Node port. So based on the requirement, you need to choose it. But here we'll be talking about deploying the application accessing by the outside world, right? So in that case, which network concept we need to use here? Load balancer. And good thing I'll do for you is whatever the Kubernetes that I'm teaching you, I'll attach it to the AWS. So that meaning the load balancer that I'll be creating will be none other than which load balancer? AWS load balancer. Your pods are here, but your load balancer is in AWS. Getting it? Good, Nana. Do you remember in Docker we learned about volumes? Volumes can be shared. Here also same concept, volumes are there. We call it as PV, PVC, but we go for deeper. So persistent, we'll talk about that. Let's not talk, but you understand the volumes right here. So if you want to store the data permanently, then you can go for what here? Volumes concept. Same concept in the Docker. And also in Docker, I also taught you to how to use EBS volumes, right? Similarly here also, you can use the EBS volume if you want to externally want to store the data. That is the volumes here. Next one is here, what here, Nana, here? Say with me, namespaces. Say that. Say that one more time. You have a habit of so many people say that, give me my space. I want to be in my space. Nice dialogue, right? Give me the space. What's the meaning of that? Isolation or not? So give me my space, meaning leave me alone. Don't talk to me. Don't talk to me, right? Don't come to me. I don't talk to you. Don't talk to me. Give me my space. Namespace. Correct, namespace only, same thing. So let's say, for example, Kubernetes is there. No, Kubernetes is a cluster. So inside this, Sham went little bit more up. Don't show your face. Okay, fine, Sham. I understand your. Okay. Everyone have their own problems. Okay. I was kidding. Okay, Sham. Okay, so namespace is nothing but, let's say, real-time requirement. I'll say Kubernetes cluster. How many clusters will you create? One or multiple? एक or दो or one single or multiple? Single cluster is fine, no? If you go for multiple cluster, you need to pay multiple times. Yes or no? If you go to EKS cluster, how many cluster you created? Those many cluster. Let's say we have 3 teams. Dev, test, prod. Say that. Dev said, we want our own parts. Good. Production people say, we want our own parts. We don't talk to dev. Testing said, we need our Bhayanak own parts. And then what you as a DevOps engineer said, I'll create only one cluster. I'll create only one cluster. Then people will go angry. If you create one cluster, that means we all need to be in single cluster. No, please give me separate cluster for every team. Dev cluster, Kubernetes cluster different, production cluster different, test cluster different, pre-prod is different, some junior will different, some senior will come, some other manager separate cluster, then you need to shut down the company. Because you need to maintain these many clusters or not. And you need to have multiple DevOps people, engineers need to be there, and then you need to pay for each and every cluster. And you need to have easy to install. Cluster is nothing but group of nodes. One cluster is nothing but minimum 3 machines. That means if you create multiple cluster into 3 times, and cost is also those many times. So it is not at all recommended to go 1 or 2 cluster is fine. But for every requirement, don't go for separate clusters. So, but this Kubernetes has given a super nice concept called namespace. What's that? So in single cluster, we can create development namespace. In single cluster, we can create production namespace. We can single cluster, we can create separate tester namespace. And each namespace have their own parts. These namespace will not talk to other namespace. Other namespace will not talk to this namespace. That's what you need. Yes or no? So we can isolate the pods using the concept of namespace. And we have by default one namespace which is called as default. What is the default namespace you have? Default namespace. Correct, Macha. I'm saying that is an interview question. What is the default namespace that you have in Kubernetes? Default namespace. A stupid interviewer, you have asked the question, you have answered the question also. Right? So, but can we create our own namespace or not? We can create it. And we can control that namespaces using RBAC. What's that? Remember RBAC? Role-based access controls. Let's not talk about it. Okay. Is this clear about the namespaces now? Jenkins में सीखा नहीं RBAC? Jenkins. RBAC in Jenkins. We created users. We downloaded role-based authorization plugins. Got it? Okay. Next one is what here, Nana? Services. Say that. I just told you about this. So we will be creating services for what purpose? To expose our applications. To expose our for the service you can assign cluster IP. For the service you can assign node port. For the service you can assign load balancer also. First you need to create what? Service. You have pods. Pods will be attached to the service. Service need to exposed using cluster. Service meaning here need to access the application or not. If you want to access the application, what is the networking concept you need to attach? Either cluster IP, node port, or load balancer. If you assign cluster IP for the service, you can access only internal. If you assign node port, you can access your application using the port number. If you access your application to a service which load balancer, you can access through the load balancer. Which one is better? External access load balancer, internal access cluster IP. Database related things, node port. Clear? Got it? Online, is this clear? Online CC. Fantastic. Okay. In Kubernetes, we need to create cluster. Everyone knows that. We can create the cluster in two ways. We can create the cluster in where? Two ways. Number one, self-managed cluster, cloud-based cluster. Say that. Self-managed cloud. Self-managed meaning what? We need to create, we need to manage. We need to create, we need to manage. Cloud-based meaning cloud will take care. So which is the cloud that we are talking about? AWS. In AWS, which is the Kubernetes cluster called, where is that? EKS. So cloud-based meaning in AWS, we go with what? EKS. But self-managed meaning, first you need to learn about the self-managed, then go for EKS. Otherwise, you will not understand the topics. For that reason, manual is first, then automation is next. So self-managed meaning here, you can go with the single node cluster. What is that? Single node. Say that. The concept itself is cluster concept. But if you go for only single node, is good. No, right? If you want to go with the single node, we use something called Minikube. Say that. What is the tool? Say that, everyone. Minikube is going for what? Single node. Which one? I'll be teaching you first with the Minikube single node. Then we'll go for the order. Okay, next one. KubeADM. Say that. KubeADM. This is for multi-node cluster, but you need to set it up everything manually. You'll go mad manually. And then you need single node cluster or multi-node cluster? Single node you need, multi-node you need. Multi-node only, no? If you want to go for single node, what is the tool that you use? Louder. Minikube single node. Say that. Minikube single node. One more time. Minikube single node. But if you want to go for multi-node cluster, and if you want to maintain it manually by yourself, everything, then go for KubeADM. Good or bad? Bad. Don't say bad. People are using it, but not recommended. But which one? Multi-node cluster, full automation. You are managing it. You are self-managing it, but in the self-manage also, you can do a lot of cluster. You can create it automatically. So which is the tool that we use here? KOps, Kubernetes operations. What is what called KOps? And some people also say COPS. What's that? COP. Yeah, sound is coming already. COPS. Not that COPS. This is K for COPS, not for C for COPS. Right? Which one we use in here? Say with me. COPS. Which one? Now tell me. Which one you want to show in the self-managed? Minikube and Minikube and which one will do the practicals in self-managed? One is Minikube, another one is, will you go with the KubeADM or COPSA? Go with the COPS. Don't go for the QADM. But you should remember KubeADM is also a tool to manage the cluster. Okay, so here I'll be showing Minikube for just a Chumma purpose one day, right? And then rest everything will go with what? COPS. COPS is a tool, but what is the command that we always use? kubectl. COPS is only to create cluster. That's it. COPS is only to create what? Cluster. Rest all the Kubernetes commands will be written using which command? kubectl only. To manage, to create the cluster, we go KOps. I mean, KOps or COPS or whichever you want. In AWS, what we call? EKS. In Azure? In Google? Correct. EKS, AKS, GKS. Is it clear online? So next year, I draw the diagram for you. Please see this diagram. Do you understand anything with this diagram? Whatever we have learned, tell me. See these diagrams. Did we already learn this? Yes or no? Very good. When you see the architecture, you should know that we have already done. Just to repeat it, what is the top one called? Master node. So the top one is master node. Also, we call it as what? Control plane. So, and in Kubernetes, remember in Docker also we wrote YAML files. In Ansible also we wrote YAML. In Kubernetes also YAML. We call it as manifest files, but we'll talk about that. Okay. So user run what here? .YAML files. Whenever we run .YAML files, first it will talk to whom, Nana, here? Kube API server. Which one? Kube. Kube API server will talk to whom? Kube scheduler. And Kube scheduler will go and then talk to the node. So which is the worker node components which always talk to the master? Kubelet. So Kubelet is the agent listen to the master. So we have Kube scheduler, and whatever that you're running, everything is stored in the etcd or not. And then we have the control manager where it will control the entire state of the cluster. Let's say Pusuk, you ran something called I need nodes, worker nodes at 5. So Kubernetes will go and set up 5 more servers or not? I'm not talking about pods. I'm talking about worker nodes. All these will be managed by control manager. So Kube. Okay. So kubectl is the guy who will be listening from the master. And then who is the guy who will be assigning the IP address? Kube proxy. And then you have container engine. What does the container engine contain? Pods. What does the pod contain here? Container. So we call it as node or call it as minion. Say that. Not onion. mini onion. No. So don't call minion also, but I'm just telling old and so there are few people, as I said, kubectl instead of kubectl, and kops, cops, and instead of nodes they called as minion. Minion. But don't worry about it. Don't use it, that word, because the interviewer will also know, will not know that word minion. Okay. Super. In NACL people call as knackle, right? Like that. Nana, is this clear till here, everyone? Online, everyone clear? Super. Then I'll be giving you, so I just wrote here what is the limitations of the Docker Swarm. I told you that Docker Swarm provide basic load balancing and no auto scaling here, right? And then do you see the difference here? Simple. Docker is used to create containers while Kubernetes is used to manage them. That's a quick difference between Docker and Kubernetes. Docker will create the containers, will use it, but whereas Kubernetes will help you to manage those containers. So in Docker Swarm, Nana, here, do I compare with Docker or Kubernetes, or do I need to compare Docker Swarm and Kubernetes? Docker Swarm and Kubernetes, because Docker is a tool. It is for another, so it is for, but orchestration we are talking about, right? Orchestration here meaning Docker Swarm. Remember in Docker Swarm, we created a cluster, master node and worker node. We have the nodes. What does the node contain? Containers. What a container contain? Application. That is on the Docker Swarm. Again, I'm saying in Docker Swarm, we created a cluster and we created node inside it. And then inside the nodes, what we have? Containers. And inside the containers, what we have? Same thing you get, but in middle, what you get? Pods. You have cluster, nodes, pods, pods contain containers, container contain applications. Okay. So I wrote Kubernetes is a container orchestration tool. Orchestration is nothing but cluster. Kubernetes create cluster, deploy and manage cluster. Cluster is a combination of one master and multiple nodes or mini onion. Kubernetes master will not take the load. Kubernetes master will take the load? Abba, no. Kubernetes will, master will not. Hey, don't create. Hey, scheduler, khabardar, don't create pods inside me. Go and talk to worker nodes. I'll just handle what? API server, scheduler, etcd, control manager. I'll manage this as a master. Pods, gates, pura, is pe worker nodes pe. Okay. So Kubernetes master will not take the load. It will distribute the loads to whom? Nodes. Which is the smallest object that you create in the Kubernetes is what? Pod. What does the pod contain? Container. Cluster is a bunch of pods or not? And pod contains what? Docker containers. Kubernetes does not understand what? Containers. Kubernetes can only understand what? Pods. And what is the features of Kubernetes? Can we do the orchestration? Can we do auto scaling? Is auto healing, load balancing, rollback? If someone asks you what is the characteristic, what are the features of Kubernetes, you can say these 5, which are powerful things. What are those? Kubernetes for orchestration, auto scaling, auto healing, load balancing, rollbacking. Omnath is asking, what is container engine? Docker engine. How we have the Docker engine? Similarly here also, we can call this as container engine also, same. Omnath. Okay, let me give a small background of it. Who is the owner of Kubernetes? Okay, okay. See, rollback meaning going to previous version with it. The origins of Kubernetes. Nana, who developed this? Google. Who developed this? Google guy developed the. But initially Kubernetes was not there. They called it as Google's Borg. Say that? Borg. B-O-R-G, Borg. Say that? Google's Borg. So Google, just imagine how much big infrastructure Google has. So Google, to maintain their own infrastructure, what they did is they developed their own tool inside to manage their infrastructure. That we call it as what? That they call it as what? Borg. Say that? So in Google infrastructure, they create the clusters and they developed their own tool that was not came out at all, right? Initially, what is that called? Borg. So that was the initial tool, Borg. Later, they have enhanced that Borg and they call it as Omega. Say that. So this is this they refined, they kept at scheduling, resource management nicely. They developed the concept of Borg to Omega. Later, Omega was the one they are using in the Google. Later in 2014, guys, 2014, and officially from Omega, they have enhanced lot of features and they called as Kubernetes. So Kubernetes was first officially announced by the Google in 2014. And it was initially developed by Google engineers. पकड़ो इसको यहाँ पे, right? Joy Beda, Mr. Burns. It's good, no? Because we don't know this. Call it is with his surname. And then Craig. Why we need? Just remember Riyaz sir, okay? Who taught you Kubernetes? Enough. That is enough for you. Who is the author of Kubernetes for you? Riyaz sir. Enough, okay? Okay. Just kidding, okay? Fine. So, yeah. So what Kubernetes, they made it as open source. What's that? They made it as what? Open source. And it was released under license of Apache license. Apache is a whole big organization, right? And it is making freely available. After that, they made a partnership with CNCF. We call it as Cloud Native Computing Foundation. At the moment, they are handling this. CNCF are handling the Kubernetes. So Kubernetes was donated to this CNCF, which is open source. Okay. Can you tell me yes or no? Whatever we have learned. Do you know master node, control panel, plane, worker nodes, pods, networking, volumes, namespaces, services? Yes or no? Do you know what is API server? I named it as the receptionist. This API is the entry point for all the commands that you give. And which is the command that I use? kubectl. That will get communicate with whom? API server. And who will take the action? Who is the action hero here? Instead of saying this will take action, I call it as action hero. Stuntman, okay? Or I call it as stuntman. Because this is the guy who will be deciding where the pod should get created and which node it should be used. Who is that? Kube scheduler. And then who will control the entire state of the control? Manager. And where it will store all the cluster data? etcd. Where, and I also told you cloud controller manager. You know API server, controller, scheduler, etcd. In worker nodes, what we have? Kubelet. What is that kubelet? Can we call it as what? Agent. And kubelet is the guy who will be talking to master. Master meaning which one? API server. Container runtime or container engine. And here, which is the component in Kubernetes in worker node will assign the IP addresses? Kube proxy. And you know the pods. You know what is cluster IP? Internal purpose. Say that cluster IP meaning internal. Node port meaning exposes external, but with the port. And then load balancer, provision the load balancer in the AWS. It used to expose all your services. Volumes concept also you know. Namespaces you know. Services you know. Services are used to access our application which is on the pod using cluster IP internal access or load balancer external. So in order to create a load balancer, first you need to create what? Service. First you create a service. After that you create a cluster IP or node port or load balancer. Minikube, KubeADM, COPS. And tomorrow what we go? We go with what? Minikube setup. Perfect. Zakas, Kubernetes. Theory, if someone asks any questions, fatafat, you should be able to answer now. Okay? But we'll be doing a lot of things from tomorrow. How to set up. First, I'll teach you what Minikube. Actually, no need to go to the Minikube at all. But still, I'll go with the Minikube. How to install, set up Minikube, and then what we do after that, we go for COPS. We go for what? COPS. KOPS. Thank you, Asif. Thank you, Tausif. Sorry. Is it clear, guys, everyone? So people say Kubernetes is difficult, but can you tell me, is it difficult? Only Reaster students will say Kubernetes is easy. Nice. Your efforts. Nice. With all use easy. Good, Nana. Komala, Anoop, and everyone. So you want to take the screenshots? Take it. So take this and then go through it. Guys, you're all heated up. You're all heated up with Kubernetes now. Just go home instead of spending time on the reels. Just spend time on my pains little bit today only, or else tomorrow while coming to the class, just sit in the class and go through once so that Kubernetes concept will be clear. So whenever next days, if I talk about API server, then you should not say, ask me what is API server. Then again, I'll start with Git now. Your wish. Okay. Yeah, next. Okay, and the next. This, especially this paint, also very important. Please remember cluster IP, node port, and then load balancer. We will be doing some projects. We'll be exporting. We'll going with the node port also. We'll be doing some things that we go with the load balancer also. So before creating node port and load balancer, everything will be created through service. Through what? Service. You remember namespaces? Leave me alone concept. Yes. Yeah. So that's the theory on Kubernetes. Tomorrow onwards, what we do? We do the practicals on Kubernetes. How to set up, install, creating pods. But mostly Kubernetes, Docker commands only. kubectl run, kubectl get pods, little bit. It's not same, but tomorrow we'll see. Yes, we can, Abhishek. But network load balancer used for different purpose. Guys, if you have application, will you go for network load balancer or ALB? ALB. But you can go with the CLB also, because most of the KOps inbuilt, they will create the classic load balancers. But if we can create application load balancers also. Very good. Okay, can you give the final CC for today, please? Second image, yeah. So that is all for today. Let's connect tomorrow with the practicals. Until then, take care. Have a nice day. See you tomorrow. Good night. Thank you, Dinesh. Bye bye.